So if I keep on changing this value, it's going to take a time. And in order to avoid that time, I have built magic method. And that method is described in this region here. So just for the header, I kept the same as you can see here. So the first is speed of the vehicle in kmph, time, and then speed of the vehicle in meter per second, motor RPM, torque, and the power. Now I will start from the first row, not from the first cell, but from the torque. So my vehicle is starting with the torque, which is 94.47, which is reference to this cell, and the power when it reaches, let's say in the intermediate speed, that has to be 32. So that's what I have referenced this cell, which is assumed value. So once we know torque and once we know power, we can calculate the motor RPM by dividing power divided by torque. It will come in a radian per second. I have to convert into the RPM. And once we know motor RPM, we can calculate what is the speed of the vehicle. And once we know the speed of the vehicle, then we can calculate the time which took to go from 0 to, in this case, 8.75 meter per second using constant torque method using this formula. And I use this formula to calculate this time. And the rest, the next is the speed in kmph is just, I have to multiply this 8.75 by 3.6 and we will get the speed of the vehicle. So this is now V1. Now the V2 is 60 kmph. That is our target value. And I have to go from V1 to V2, now constant power mode. So if I use this formula, which I can supply V1, V2, and N is 100 here, ADC which I am getting from here, then I am able to calculate the time which is required to go from here to here. And if I calculated using this condition, I got 8.6, but my target value is 8. So I'm going to use our best friend, which is goal-seek method here. So I'm just going to use this. What I need, 8 seconds by changing this power. And now I have reached 0 to 60 in 8 seconds, and the final power I just got it, which is 36.8 kilowatt, which is lesser than the previous value that we got it. So this is the smart method that we found out. But before we go ahead, I would like you to pay attention to this graph here. So using this column, I draw this graph. The graph is the torque, power, and speed versus motor RPM. The first is torque versus motor RPM. The torque, I took it this L column, and the motor RPM is K. The next, I draw the curve power, which is this, versus motor speed, which is K. And then the speed of the vehicle in kmph, I took it this value, and then the motor RPM. So the torque in a blue, the speed of the vehicle in green, and the power of the motor in the red. So see the motor. So it started here at the constant torque, which is 94.5, and then constant, it went till here, and then after it switched to the constant power mode, and then it reached here, and then we achieved 60 kmph at this point. Similarly, you can see power increases from 0 and went to 36.8, and then after it became constant. So as I was telling you before, we can draw this motor characteristics curve, and that's what you see. You got this peak motor characteristics curve using the acceleration driving mode. Now come back to this fun with the vehicle dynamic, and then now change this value. So motor speed is going to be the same, Why? Because you see the motor speed is 6160, because final velocity is not going to change. But now the torque is became 57, hence I am going to replace with 57, and the final power that we got 36.8. So this power is much lesser than the previous power, which is 54.79, and the final torque at the end of 60 kmph is 57. But it started with 94.5, it went constant till certain speed, and then after the torque started decreasing in order to maintain the constant power. So finally we found the smartest way to go from 0 to 60 kmph in 8 seconds in the less power, which is more optimal, which is more desirable, because we will able to save the battery energy.